So here we are. Good afternoon to Europe. Good morning to North America. And just a friendly hello to the rest of the world. We would like to welcome you to today's Python webinar. It's the first time we do a jointly presented webinar together with Safe Software. And first, I would like to welcome Ken Bragg. He is from Safe Software. Good morning, good afternoon, Ken.
Yeah, hello everyone. Thanks for joining.
So Ken will give introduction into FME in general in a few minutes. And next will be to introduce today's presenters. We have Tino Miegel, our software engineer and FME and Python expert. Hello, Tino.
Hi, everyone.
And in the back, there is Stefan Offermann, again, a great Python expert and the man for the chat room. So if you have any questions during the webinar, feel free to ask just the questions in the chat room. You have a chat or a message box in your toolbar on the go to webinar toolbar. And last but not least, myself, Christian Dahm, I'm a consultant for FME technology. In the next 60 minutes, we would like to give an overview about FME and Python. And I think we should start. And we will start with the first poll, and I will hand over to Tino.
Yeah, before we start with a real looks good. Okay, nearly all people have voted. I will close it in 2 once now. Let's have a look. I can share the results. So many experts here in the audience, and no
it looks
one.
Like that's true.
Really nice. Okay, so this looks good, especially for this more technical Python webinar. Okay, hide and let's go on to the first slide, and we will give back to Ken, who does a short introduction. Ken.
Thanks, Tino. So it looks like there's no one who hasn't used FME before, so I don't have to spend too long describing what FME is. This morning we had a few users. We ran this session this morning, and there were a few people who had never used FME. But Python and FME, it's a big topic in a way, but it's actually a small part of what FME does. FME's been around since 1997, and we are kind of known for translating spatial data formats from one to the other. And in this diagram you see here that each of these little circles represent, in a way, types of data in which there's many formats that FME supports reading and writing. So early on at Safe Software, FME was often used to translate between CAD and GIS formats, so it might have been used to go from AutoCAD format into shapefile. Now you can see that there's many other areas of data that we support in FME now, lots of raster formats. XML has been a big push for us lately, using FME to read and write XML formats. Now we're more and more supporting 3D formats like 3D PDF and Oracle Point Cloud. And the web category refers to formats in FME where we can read from web services or create web services. Next slide, please. This is FME Workbench. I think almost everyone in this session probably knows about Workbench, but FME Workbench is the tool we use to author or define data translations. So in the picture here is a fairly typical workflow where we're reading from one format. The brown box that has a bookmark labeled source data represents the data that we're reading from. So in this case it's a mapinfo tab file. In the middle there, the bookmark that says transform, this includes transformers. And more FME is used to not only translate spatial data but to transform it, to change the schema, to change the geometry, to change attributes. So there are literally hundreds of transformers in FME now where we can do all kinds of processing on features as we translate them. In this image, you can see the area calculator transformer finds out the area of features. There's an attribute renamer to change the name of columns, and a counter just to simply count how many features there are. And then on the right-hand side, we have the writer. So this is the format that we're writing data into. So there's many, many things possible in FME with the readers, the writers, and the transformers before you even start to think about Python. But that's the focus of our talk today. It's kind of an advanced topic for FME, but using Python and FME unleashes a whole bunch of potential that doesn't exist within the transformers and the readers and writers. So I'll hand it back to you guys. Thanks a lot.
Thank you, Ken. And we will hear you later on again. And now let's have a look at today's agenda. We will start with a quick overview about Python in general. Then we go on with FME and Python. And the last part will be best practice sessions or some tips and tricks about using FME with Python. So if we have a look at the next slide, we see that we have a next poll.
Yeah, again, a short poll just about your Python knowledge. So we get to know you better, or our audience to get better. That looks really good. So I will close the poll in 3, 2, 1. And as you can see in the results, yeah, it's really good, because then we can concentrate on the FME Python integration and not on the Python itself. Okay, so let's go on with the slides.
So even if you're mostly familiar with Python, we want to give a short overview about some Python basics. So first of all, Python is a scripting language. In a way, it's easy to learn and use because it has a very clear and readable syntax. We would say that it's well documented. It has a great and growing user community. It's platform independent, so you can just use it on any platform you want. And yeah, of course, it's a great tool for GRS automatization tasks too. Yeah, it's free, and yeah, that's enough for the overview. So more details you can find on www.python.org. So on the next slide, we have a few things about a few Python basic things. The first thing is variables. So there are different data types like strings, integers, float, lists, dictionaries, and tuples. And there's something which is very special to Python that's called dynamic typing. That means that if you define a variable, there's no explicit declaration of the variable type. As you can see on the right-hand side, you can just type a equals 1, and it's an integer. And you can just type b equals hello world, and now you have a string. So there's no explicit declaration that says, okay, a is an integer or b is a string. So it's dynamic typing. The second thing is something called built-in methods. I think you can also say ready-to-use functionality. So there are a couple of functions you can just use without importing any DLLs or something. Some example functionality will be, for example, the length for length calculation to calculate the length of a string, for example. Then you have max min function, or for example, a print function to print out information. And you can, of course, extend these built-in methods through something that it's called modules. And modules, maybe it would be a good explanation to say that modules are thematic grouped extensions. And there are maybe hundreds of modules. For example, a math module for doing math calculation, OS model for operating system. We will see this in our first sample. For example, zip or RE for regular expressions. And we will learn later on that there is a module for FME too. That's called FMEObjects, and you can access all FME functionality through that module. If you start to write your own Python script, you can use nearly any or every text editor you would like to use. But if your scripts are getting more complex, you should use an IDE, for example, the idle, which ships with the Python installation, or maybe PyWin, or a plugin for Eclipse called PyDev, or from Google there's an open editor called PyScripter that does only just a couple of ideas to share with you which IDEs you can use. And I think now it's time for our first sample, and I will hand over to Tino.
Yes, thank you, Christian. So here we have it, our first Python code or first Python script in this webinar. Some words to structuring Python code. The first and most important thing is commenting. So 2/3 of your code will be command lines, and these are done in Python with hash signs in front and colored here green. So we have the first sample 1, and then print even numbers, which state what does our code, print even numbers from 1 to 9. So these are code lines. They don't do any actual processing or something. Then what do we next? We define our variable a range. So the range command in Python assigns numbers from 2 to the variable. So we get a list with numbers from 1 to 10. Then again, a short comment. So here we start our for loop, and then we loop over a. And for every number which is contained in a, we test. We do a modulo and check if it's O, and then we have an even number, and we print out a statement number which we test is even, and in the else case, we print out number is odd. So, and one very important thing in Python is code structuring with line indentation. So it doesn't matter if you use tabs or spaces, but you have to use only one throughout one script. So if you start with some indentation with 3 spaces, you have to use 3 spaces throughout your whole script. If you start with tabs, use tabs. So that's a bit different from other programming languages. In most cases, you use brackets to structure code blocks. In Python, you use line indentations. And to show the script live, I will switch to the Python idle IDE, which as Christian mentioned. So this is our shell, and you see the result from run I did a few minutes before the webinar. So this is an interactive shell, and where you can directly start typing code. So you can print something, hello world. So I print out a string, or I can do some calculation, 3 + 5. I can assign this, and again print b. And so you can see you don't even need to finish your code. You can just test code statements, Python statements directly in the shell. And back to our first sample. So here you see the same code from the slide again, the loop. And I will just run this, run module, and it switches back to the Python shell, and it does our 9 statements with statements about the numbers if they are even or odd. So just for a start of Python. So we have to get a feel for how Python code looks. And we will do, of course, more pricing later on in this webinar. So I will give back to Christian.
So after a few Python basics, we are coming to FME and Python. And there's one question why and when should one make use of Python with FME Workbench? And maybe there are some reasons. And one reason, maybe if you are planning to do automatization tasks with FME, you can just call any workspace you would like from your Python script. And in a few minutes, Tino will show us an example for that. If you are looking into FME Workbench and you are missing the right transformer, so you're missing functionality, you can just start and write a few lines of Python code in, for example, the Python caller or in the Python creator. We will see this later on too. And another reason maybe if you wanted to carry out tasks before or after your translation automatically, you can just use a Python startup or shutdown script within FME Workbench. But before you start working with Python in FME, you should always look for an existing FME transformer or functionality first. So do not start writing your code and then looking in the transformer gallery for the right transformer. So you have to do the other way around. First, look for an existing functionality, and if the functionality is missing, then you should start writing your own lines of code. And again, it's time for sample number 2. Tino?
Yes, again a sample. So at first we want to show how to run a workbench from Python. So for the first time we switch to FME here, and this is our FME Hello World example. What we do, we just create a point, then we assign a text here. As you can see, this is a string. We have published the parameter, and we will start the visualizer here so you can see the result. We don't write it to disk. And we have one published parameter which allows the user to set parameters for the workbench. So here I can enter the string which we want to show, and the workbench runs. The visualizer, the viewing component of the FME desktop components starts, and we see here Hello World. So this is a FME Hello World. And starting point for this is, let's have a look into the log window of our workbench, and you can see here it prints out the Windows command line statement. So this we could copy to our command line, to our command shell and run, but what we we use it in Python. So let's get back to my Python IDE. Here we do first import a library, the already mentioned OS library, which allows us to run system commands. And then we use the function OS system to run our actual command. As you can see here, it's a call to fme.exe, and the path to our workspace. And the last thing is we set the published parameter with parameter name, minus parameter name, parameter value, here hello Python. And when I run this, F5 or run module, you can see here is a very simple implementation. There is, you can see for a second the command shell from Windows. It is possible to suppress us. We will do give a hint in the follow-up. There is another module beside OS who allows us to do more complex process starting. But the main point is here, again, the same effect where the FME processes our data, in this case a Hello World example, and starts the visualizer, and we can see here Hello Python. So why do you want to do that? Perhaps one thing is, it's the main thing for me, I can't code batch, Windows batch. I never get the syntax correct. So for me, it's very easy to write a Python script, but you are not so limited like batch files. So you can do more, very complex chaining of different workspaces. You can, in the same script, you can copy files before, after translation to other files and do many more things than to simply create your batch file to run workspaces. Okay, back to the slides for now, and back to Christian.
So thanks, Tino. And after looking how we can call an FME workspace from outside, we dive now into FME Workbench. And yeah, there are at least 5 places where you can put in your Python script. The first thing is startup script, shutdown script. Then we have 2 transformers, the Python creator and the Python caller. And the last thing mentioned here, it's very new to FME. It was introduced in FME 2011, and it's called private scripted parameter. And in the following slides, we will have a close look onto each of these 5 parts. So the first thing is startup script. So the startup script is always executed prior or before the actual FME translation process, and and there are a couple of reasons or uses for that startup script. So the first thing, maybe you can define your own Python functions in a startup script and use them later all over the FME Workbench. Then you can, for example, check your database connection. So if your database is not running, it doesn't make sense to run the workspace. So just first check the connectivity and then run the workspace. You can, for example, just move data from one place to another, or copy, for example, a template file. One thing very special is that you can add your own custom messages to log file. And Tino, I think we will show this in our best practice session.
Yes, we do. Cool. Later on.
Cool. And yeah, another thing is accessing any FME macro values. So for those who do not know the term FME macro values, that's something like global parameters, which are accessible throughout the whole FME Workbench. And for example, if you define a published parameter, that's getting a part of the FME macro value directive. If you you can see on the right-hand side there's a navigator window, and under workspace parameter, under advanced, you will find the startup Python script and the shutdown Python script. So it's a bit hide, but now you know where you can find these 2 parameters. Let's see what the shutdown script could do for us. So the shutdown script is executed after all reader and writer work is done and the process is finished. And it doesn't matter if the process finished with success or with failure. So the shutdown script is always will always run. So, and there again, there are different potential use for that. For example, you can imagine that you can do any kind of post-processing, and maybe one good example would be to call the ArcGIS scripting environment through ArcPy. So you can combine FME and ArcGIS technology through Python in the shutdown script. Maybe that's a good example. Or you can just access any statistical information about your translation, like how many features are written, or how was the CPU usage time, for example. Then you can just copy your result files to the place where you want to distribute it. Or maybe another good example would be to just to automatically write a success or failure email if your workspace was successful or failed. And we will see this as our next sample, sample number 3, and I will again hand over to Tino.
Yes, switching back from the theoretical part to the practical part. We now switch to the FME Workbench, and here we have it. A very simple translation process. We translate map info tab files to shape files. It's not so much done here, but more important is what we want to do afterwards. If this process has finished, we want to send the user an email, and for this we have implemented a published parameter here which asks the user for his email. And so here is a dialog. We can enter an email. And what we do in the startup script, again here you find the Python scripts under advanced startup Python script. Look, so this is a FME built-in Python editor. We again import a package library, the regular expression library, which helps us to check strings, to verify strings, and we use it to check if the email is correct. And if the email is not correct, we raise an exception, so this causes the FME process to stop. So this means if the email is wrong, no data translation will happen. So let's see how this works. I start the process. So now I made a typo. Of course, not all typos can be detected, but this can be detected. We forget the dot between the mail domain and the country suffix. And now the translation failed. So the email is not valid. Process has stopped. Okay. So the next thing is I correct my email. As you can see, it's checked and the actual data processing happens. And again, our shutdown script is evaluated. What it does, let's have a look. Here we have get an email from our process, and it even it contains the message, it was successful, and it even contains our log file. So from within the mail we can download the log file, and perhaps on a very different computer than the FME we can check our log file. So how is this done? Let's go back to the workspace. Let's have a look at the shutdown script. So this is a bit more Python code. So you are able to download all these scripts a few days after this webinar to test and to implement your own routines or to change to your own mails. We define some variables we will use. So we need, of course, a sender address. We need here, we access the FME macro value email. So to get the user entered email, we need the password for our mail account. We have a subject. Here we have a setting if we want to attach the log file. And the host, we use Google Mail for sending. And perhaps the most important is here, we check the variable FME status. This is a global variable which helps us to determine the status, the outcome of the process. And we can attach the the correct message into our mail if the translation was successful, or the else cause it was a failure, the translation failed. We can even attach the failure message from FME. So, and this is our only configuration which you use to configure later on your script. Here is the main Python script which does the email sending. And again, here use an external library. You don't have to code it all yourself. You can just use SMTP library. And then we don't go into every detail here. So as you can see, that's not so many, 22. So it's about 35 lines of code where we build the email, connect to our SMTP server, and again send the email. So last demo, what does happen? I include a terminator to our workspace to let it fail on purpose. I run it again. FME does remember the last values for published parameter, so it sends to the same email address I entered the run before. And here you see again the same email, but again now we have the message the translation has failed, and it does include the translation failed, which is translation terminated, which we did on purpose. So this
That's pretty cool.
was the first. complex. Of course, this is built in FME server. If you really want to do much processing and much email sending, you can use server. Then you don't have to use Python code. But it's a very nice way to implement email sending in your FME desktop when you perhaps run on a nightly schedule some processes. So back to the slides on the next Python integration in FME.
So now we have Python creator and Python caller, so two transformers. And as you can see in the screenshot, the Python creator has just an output, so it can only create FME features through Python. But on the right-hand side, we see the Python caller, and it has an input and an output, and therefore it's possible to create and manipulate existing FME features. So that's the difference between the both. The Python creator only creates FME features, while the Python caller can also manipulate FME feature. What they both has in common is a parameter dialog. The next slide, we will see that there are three parameters in Python creator and Python caller dialog. And the first parameter is the Python script itself. So that's the place where you put in your Python code. The second parameter sounds a bit strange. It's called the entry point, but we will see in a few minutes that is just the name of the function or the name of the class you write or you implement in your Python script. We will see this in a minute. And the third parameter is called attributes to expose. So if you are going to create new attributes in your Python script, you have to expose, so to make them visible in FME Workbench. If you are familiar with the FME Workbench, you know that there's a transformer called the attribute exposer, and that's exactly the same. So it's just to make new attributes visible in the FME Workbench. And I think, Tino, it's again your slide. Next slide is your slide.
So here you see the first, more easy way to manipulate features in FME via a function. So you want to use this if you want to manipulate one feature at a time only. So not only one feature at a time, so every feature which enters your transformer, but you don't want every feature and put it out, and there are no dependency on the features. So again, you implement a function which shows here with the keyword def, and again the function name will be your entry point. And of course this is only available in the Python caller because the Python creator has no input port, so there are no features you can process. You can only create features. And if you add the Python transformers to your FME Workbench, they are already filled in with these templates, so you don't have to start coding from scratch. There will always be a small template which shows you the function and also the class we will see on the next slide, and then you can implement your functionality. And what we do here is very simple, just to show it. The function gets the feature from FME, and then we do a buffer on the feature. And the second thing is we add an attribute status with the value buffered. So these are only two operations, and this is it. Nothing else code. If you subtract the two command lines, 3 lines of code, and you have buffered your features and added an attribute, which is the same function than the transformers, but it should show here that you can what you can do with Python. So if you want to do some more complex working in Python with features, you have to implement a class. Again here, this is the class keyword and the class name, which defines your entry point. And then you have to define 3 functions in this class. This is the init method, which gets called with the first feature. When the first feature enters your transformer, it is called. You can do some starting, like logging a a status message in your log file. Now I'm starting my own processing, and some other things. Then the second method is the input method, which here gets the mouse, which gets the feature, the actual feature, and then again you can do manipulation of this feature, but here you have to give it back into the FME pipeline. That's different from the function. Here you have to call the PyOutput method from your class. That means the self, and give it a feature back after you have processed this. That allows you also to filter. So perhaps you don't want to put out every feature only once, and then for the other features you won't call the PyOut. And the last thing is the close method. And then again, you can use the close method perhaps to put out a log message. Here my own processing stops. And again, you can perhaps use again PyOutput and perhaps create a new feature which contains some statistics regarding all the features you have processed with your input method. So, and also this class fragment, so this template for a class you will find in the transformer. It's built in, so you only have to implement your own lines of processing the features. Yeah, and where do you find information for this? As you have seen the last two slides, here we process features. So what is such a feature? It is an FME feature from the FMEObjects module. And beside the definition of features, there is many more functionality in the Python API, like FME geometry. So you can manipulate the geometry of a feature, or you can create new geometries. And also you can access the log file to what I've said to state your own log file message, and many more. And for every, it is mandatory, of course, if you want to do real Python coding with FME, to have a look at the documentation of this, and you will find this in your FME home under Help Python API doc. It is a simple variant which you have always installed, and there is a more complex API doc with more information which you get when you install the SDK. This is an option when you install FME. You can check a button and then this SDK documentation.
And can you show
yes,
your API documentation?
Yeah, so
that's cool.
This should be familiar for programmers. It looks like perhaps the Java API doc. We have on the left we have a structure, so we can find our modules, which is only FMEObjects, and here you see FME exceptions, FME feature, the classes which are available, and perhaps we have a look at FME feature. So the class FME feature, and here we see the feature. Does this have this buffer function which we have used in the function example on the last slide? So here you can find all the information of FME object methods, classes, of all the things you can do with FME objects in Python. Okay.
That was good timing. That was good timing, Tino. We just had a question about that right as you were talking about it, so that was great. People out there, please feel free to type other questions in. Stefan and I haven't been too busy with the questions yet, so we certainly welcome any questions you want to send.
Yeah, we have 2 persons only for your questions here, while Christian and me are talking, so feel free to ask anything. And if you have very interesting questions, we will get back to you at the end of the webinar if you have some time left. Otherwise, you will get a follow-up email from us with information about your questions. Okay, so to put this to use, the mentioned transformers and coding, I'll give back to Christian and even give him the mouse to my computer, so he can show us a nice workspace. Let's
so
Christian.
He implement an example which we call Python Olympics, and in a few seconds you will get an idea why we call this like we do like Python Olympics, Python Olympics. So as you can see here in the workspace, we have 3 transformers, 1 Python creator and 2 Python callers. And I'm not sure if I already have control over the workspace.
You should.
Should.
Yeah, you have mouse. Try.
Okay, gonna try it.
Yep.
Yes, now. Okay, let's have a look at the first Python creator. So it's there to create features, and we define an entry point called feature creator. And as you see in the Python script, it is just the name of the class we implement here. So what have we here? We have defined a variable called self.olympicrings, and we attached some coordinates and some information about color, and we attached at least 5 items, so 1, 2, 3, 4, 5 items. And in the close method, we implement a for loop, so we loop over the elements here, and for each element we create a new FME feature in this line. Here you see that we are calling FMEObjects.FME feature to create a new FME feature. And we assign 3 attributes, an ID and 2 information about color. As you can see here, fill color and color. And the next line here, we create a geometry, in this case an FME point, and we assign the coordinates which we defined here as a tuple to that FME point. And then we set the geometry to the FME feature, and we output the feature, and we do it for each element here. So we have 5 features outputted here. And if I run the workspace, here we go, you will see that we just created 5 points, 5 different colored points. 1, 2, 3, 4, 5. I'm not sure if you can see this, but that's not that important. So if you close the viewer and then go over to the next transformer, the Python caller, the first Python caller, we take these 5 features and manipulate them. We define first an entry point called buffer feature. So maybe you have already an idea what we'll do in our Python script. We define a function to manipulate each feature separately. What we did here is we just make a copy of each feature. So we use the method clone to copy or to make a clone of a feature. Then we buffer the original feature, and we buffer the copy of the feature, and then we are creating or making a donut from both, from the original and the cloned feature. And if we again run the translation, you will see and maybe get an idea why we call this the Olympic rings, because we created Olympic rings through Python. Back to the workspace, disabling just here and enabling this inspector. Now we again take the 5 rings into the Python caller, and we define an entry point called aggregate. And here now we have again a class called aggregate, of course, and we define first a list, an empty list, and we append all incoming features into this list. And in the close method, we first create a new FME feature, and we build aggregates from all incoming features and put out the new created feature. And what's remaining is just an aggregate from 5 Olympic rings into 1 rings made up 5 geometry parts. So here it is. Let me just mention that, of course, you can do this example without write any line of Python code, of course, but it was just our idea to show how Python Creator and Python Caller work in general. So back to our slides. And the last thing you could do is create a private scripted parameter.
Yeah, thanks. So more Olympics in London, more Python and FME now here. So the last way we will show today, so of course there are many more ways to use Python FME, is the rather new private scripted parameter you can use in FME. Perhaps the FME users know published parameters. There are different type of parameters you can use. As we have used for the email, you can have text fields, you can ask for passwords, you can ask for files. There is a published parameter for floats. There's even a slider, I think, and many ways, and like choice with alias. And the private scripted parameter is new. It lets you use Python in the scripted parameter. So it helps you to do perhaps really complex processing before you give the actual result into your workspace, perhaps for a transformer. So we're a bit in a hurry, so I will switch to the example for this. Here we have a workspace, and as you can see, we read a couple of layers, or we have a couple of layers in our source data available: rivers, roads, rails, buildings, and school buildings. And we have grouped them thematically. So we have a water theme, a transportation theme, and a building theme. And we want to let the user choose which layers gets read from the source data, but he only should choose between water, transportation, and building, and we then want to decide which layers to read. So what we have done here is then, of course, created a published parameters, just this text string, which asks the user a choice. That's a short look. So here, this is published parameter. If I start the workspace, I can choose one or more of the themes. And then we have a private parameter. Python scripted parameters can only be private because, of course, you want to hide your code from the perhaps Python affine user. And here, this is our Python code. And what we do here, we check the macro values layer. This is a user selection. We check for the string transportation. And if user selected transportation, we want to read the layers rail and roads. And if the user has checked building, we want to read buildings and schools. And the last thing, if he chooses water, we want to read rivers. And according to his selection, we build up a string which contains all layers to read in the variable feature type. And then we will, this is very important in the script, we have to return something. This is our actual value. We return here our strings with layers. So, and then our reader should make use of this. Let's have a look at the navigator. Here are all our parameters and very high, it's very hidden and advanced. Here we have feature types to read. The FME experts do know this. Here feature types to read determines which layers we read, perhaps from our source data. So this gets the value from our Python script, the value we return. Let's see the action. So here, perhaps I only want to read the water layer. Oh, please, the water layer I should choose. We only read the water layer. And you see only rivers are processed. And let's see the other way around. We only want transportation. Choose transportation. And then the two layers, roads and rail, gets read. So this is a very nice way to hide complex functionality from the user or do a more complex mapping. So here it is only 3 themes to 5 layers, but you can imagine more complex situations where you perhaps even use some calculations. Perhaps you want to ask the user for a year, and according to this year, you want to expand the year to a area of 2 or 3 years, so you can add something with your value script to, or you can create a complex SQL statement. Then you then use to access your database. Okay, so now some best practices when you put this all to use. Christian.
So yeah, the first best practice tips and tricks is defining or creating a custom transformer. I'm sure that most people know what a custom transformer is. So you can just take your Python creator or your Python caller or both, put your Python code in it, right-click on it, and create a custom transformer out of it. So it's just a good or an easy way to extend your list of available transformers in the transformer gallery. Just create your own custom transformers, and if you need a special functionality, you can just put in your own custom transformer, and here you are. And what is important to custom transformers, of course, is that there's a possibility to give them a description. So if you search for special functionality, just type in the search window in the transformer gallery some words, and you will find the transformer you have to use. And I think we have one more best practice, don't we? We have.
Yes, we have. The second thing is, you mentioned it before, don't be sparse with your comments in the code, and don't be sparse with your log messages. And perhaps it's very easy, and many people start with this. They use print statements to put something into the log window here. So this is important. If you do print statements in your Python code, it doesn't matter if it's a startup script or it's a caller. In your Workbench, you will see those statements in the log window, sometimes only at the end, so when the translation has finished, but they won't get written to the actual log file. So what you have to do is to put something into the log file, is to use, again, FMEObjects. And there you can see it on the slide. You have a class, the FME log file class, where you can use different functions to log different severity level info messages. So, and these messages will both printed in your log window of FME Workbench and will get written to the log file. And perhaps very important, if you later use your workspaces on FME server, then print statements get lost. There are no way to view it because you have no screen session on your server, but messages you initiate here via log messaging to your log file, they get written even by FME server to your log file and will help you for debugging your scripts. So
one question, if we can show a custom Python creator. Do we have a Python creator ready to use? Or maybe we can download the one from the FME store, the fuzzy string comparer, maybe, to show people how a custom transformer works.
Perhaps
you just type fuzzy.
Yeah, that's a good idea.
Yeah, so this is the UI. You just the quick add in FME. So on here you see fuzzy string comparer, and the green arrow shows this is not a local transformer. It will be downloaded. Let's try. Oh, I have used it before, and this is our fuzzy string comparer. It's colored differently from other transformers to show you how does it work. And I'm not sure if I can edit it.
Yeah, I can edit it. Yeah, that's cool.
So I'm not sure if perhaps later on some transformers are protected. I think so, if you want to sell one. But this is, so as an example, it is not protected. You can edit it, and it opens a new Workbench window. And here, this is functionality.
And there's a Python caller in it.
Yeah.
Right in the middle. Let's see what we do. Calculate similarity. Yeah.
Here. So you see, it's not much code, but it's really effective.
Yeah.
It calculates a ratio, how comparable, how similar two strings are.
I think that's very useful, isn't it? Cool.
So it detects perhaps names, sure names, which have only some minor typos, and you can detect them as the same. Okay. So
in fact, we had a question.
Yes,
In fact, we had a question in support about that exact thing today. Someone wanted to know if there was the SoundX function available in FME, similar to Oracle, and that Python module is very similar. So that's great.
Okay. Cool. Okay, then we have documentation. If you start working with Python in FME, you should have a look at the FME Workbench transformer description, and of course the Workbench help. And yeah, we had already the FME store with a fuzzy string comparer, and I think in the future there will be many more Python-based custom transformers. Like always, the FMEpedia is a good starting point. If you're starting working with FME and Python, just type in the search field something like Python, and you will get a couple of articles about starting working with FME and Python. And I think it's again time to hand over to Ken, and he will give us an idea what the future plans about Python and FME are. So Ken, it's your turn again.
Thanks, guys. That's been a fantastic introduction to Python and FME. I'm going to go through this quickly because I think we're running a bit low on time. But someone asked a question already about accessing the shutdown or startup within a transformer. You can't do that yet, but that's something we're definitely doing for 2013. We'll be enhancing the Python callers so you can create your own ports. Point number 3, we'll probably be replacing some functions inside FME that use TCL currently to use Python because we think we may get some performance benefits there. Scripted parameters, we will hopefully be able to return more than one value. And the Python plugin SDK is coming, and this will let developers develop their own formats for FME using FME Software Development Kit using Python. So that's probably going to be more like 2014. But of course, at SAFE, we really are motivated by customer feedback. So if we hear from you saying, please, please do this, it motivates us a bit more to do things. So thanks again, and I'll pass it back to the guys at Contera.
Okay, thanks, Ken. Yeah, so last thing, now Python script, but the last poll we have. We would like to know if you are interested in more webinars, perhaps not only on Python, perhaps more advanced, perhaps even on Python, FMEObjects, and the API in the future. So we give you again a few seconds. That's really interesting. Oh yeah, I think there will be definitely some more webinars. Let's stop the poll. 3, 2, 1. So here we have it.
Oh, that's cool.
That's cool. So it's a 57.38.5% are not interested. So you will see and perhaps better hear us again, I think. So back to the last slide.
Slides, what's next? So the FME World Tour is still on the road. If you want to take part, just check out. If you want to register for the FME newsletter, just go to safe.com/newsletter. And then if you want to give a try to FME Desktop, just download it from the link mentioned here. And what we should say is that today's webinar was recorded, of course, and within the next 2 business days we will send you an email with this recording.
We did use a bit more actual technique to record it, so you can watch it on your computer.
And I think our last slide says thank you. And if you have further questions about Python and FME, or if you are interested in an FME training, here at Contera we offer both basic and advanced trainings, and we do on-site training all over Europe too. And we have, I think, 5 or 6 certified trainers and professionals, so enough power to support you. And yeah, just contact us via email, fme@contera.de, or via phone, for example. And yeah, I think that's it.
Yes. So thank you again for your attention.
Yeah, and thank you, Ken, for supporting us.
Yeah, thanks guys from Contera. That was great. Just a note for North American people from North America in the audience, there's North American partners from Safe Software. You can contact Safe Software directly as well if you want to do some training on FME in North America. So that would be at safe.com. So yeah, thanks guys, and thanks everyone for joining.
Okay. To the Europeans, have a nice evening and others a nice day.
Yeah.
So we will finish here.
Saying goodbye.
See you again.
Goodbye.
Bye-bye.
Bye.